Okay, these are the notes for 1.1 arithmetic and geometric sequences. We're going to brush through these real quick. We're not going to read the whole thing, as I said earlier. So if we scan down the page to the Explore section, okay, we've got two different sets going for sequence 1. Basically, what they're wanting to do is say, okay, for number 1, for the first item, we have how many different toothpicks? Well, 1, 2, 3, 4. There are 4 items in those toothpicks. All right, for number 2, there, if you count them up, 1, 2, 3, 4, 5, 6, 7. There are 7 toothpicks. I had a lot of people say 8 in the classes. That's because they saw, oh, well, 2 squares. That means 8 sides. True, but if you count the toothpicks, there are 7 toothpicks. All right, for number 3, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 toothpicks. So for item 1, there are 4. Set 2, for number 2, there's 7. And for number 3, there's 10. So skip down to the next page real fast. Scroll down to the next page, and we're going to fill in this sequence real quick. Okay? So for number 1, there were 4. Number 2, there were 7. And number 3, there were 10. All right? So the first thing you should notice is what's the difference between each one. For each one, we are going up by 3. We're adding 3. We're adding 3. We're adding 3. Okay, so number 4, if we're adding 3, number 4 would have 13, because we added 3. Number 5, we would have 16. Number 6, we would have 19. And number 10, we would have 22. No, we wouldn't have 22. Well, I skipped everybody on this all day long because they went from 6 to 7. Well, the chart goes from 6 to 10. So from 6 to number 7, 19 plus 3 is 22. Add 3 to get number 8, that would be number 25. Add 3 more, that would be number 28. Add 3 more, we finally get to 31. So this would be 7, 8, 9, 10. So for item number 10, you would have 31. All right? So that's for sequence number 1. For sequence number 2, if I scroll back up, all right. For the second one, for the first item, we have. Oh, come on. For the first item, we have 1 little disc. For the second item, we have 2 discs. For the third item, we have 4 discs. And for the fourth item, we have 8 discs. So we got 1, 2, 3, and 4. 1, 2, 4, and 8. Okay? So, let's go skip over to the next page and fill those in. I wonder if we can. Nope, we can't. So just a second. Okay, so I just filled in that part on the left real quick. For sequence number 2, for that first one, you had 1 disc. For the second one, you had 2 discs. For the third one, you had 4 discs. And for the fourth one, you had 8 discs. So take a second. What did we do? We multiplied each one by 2. Okay, so 1 times 2 gave us 2. 2 times 2 gave us 4. 4 times 2 gave us 8. So 8 times 2 will give us 16. 16 times 2 will give us 32. And so that's for number 6. For number 7, 32 times 2 is 64. That's for 7. For 8, 64 times 2 is 128. For 9, 128 times 2 is 256. So finally, for number 10, 256 times 2 is 512. Okay? So we could technically do this forever. If you want number 11, you multiply 510 by 12, by 12. If you want number 11, you multiply that one by 2. And so on and so forth. All right? Let's keep going. The rest of these ones on this page, you'll notice we answered all these questions. So like number 1 right here, what pattern do you observe in sequence 1? Well, we added 3. Number 3, it says how did the pattern, okay, number 4, it says how many toothpicks would you need for the 10th sequence? Well, you needed 31 to make the 10th sequence, and so on and so forth. So we pretty much answered these. Let's go to the next page where it says reflect. All right, this is kind of an important part. It says, which sequence has a constant difference between the number of objects? Well, I know you can say that both of them were kind of constant. More of them were both consistent. The first one, we added 3 to get the next term, then we added 3 to get the next term, we added 3. So the space between each one, 4, 7, 10, 13, the amount of space between each one, the difference was the same. Each one was 3 spaces away from each other. So for this one, it's number 1. The second statement says, which sequence has a constant ratio? Okay? Ratio means multiplied by. So difference implies adding or subtracting. Ratio implies multiplying or dividing. So which one has the same multiply or divide between the two? Well, that would be the second one. Because to get from number 1 to 2, you multiplied it by 2. Then to get to 4, you multiply by 2. For number 8, you multiply by 2, and so on and so forth. All right? And here's where we kind of start getting into the crux of the lesson. All right? Number 1 is called an arithmetic, A-R-I-T-H-M-A-T-I-C. You may have heard this pronounced arithmetic. Arithmetic is the noun way you spell it, but if we're using it as an adjective, we call it arithmetic. So this is an arithmetic series. That's when you're adding or subtracting. When we are multiplying or dividing, we call it a geometric series. And that's what we're talking about today. Arithmetic and geometric series. Okay? So, let's keep on going. If I scroll on down to number 1. We're not going to read all of this, but for number 1, if this is my sequence... Oh, come on. There we go. This is my sequence right here. Okay. Is it arithmetic or is it geometric? The thing to look at is we are adding each one. Since each one is the same plus or minus, this one is arithmetic. Okay? And this will be the formula you use. Okay? So today, we need to do more than anything else. If you get nothing out of this lesson, we need to talk about what do they mean by a to the n and a to the n minus 1. It's a notation series that you need to learn. That is the crux of today, if nothing else. So here's what we mean. A to the n means, if I say a to the n, this n right here simply states which item. Okay? It doesn't mean multiply by anything. It doesn't mean divide. It doesn't mean raise to the third power. Anything. It is simply telling which item we're talking about. So, the 11 up here is item number 1. So it would be A sub 1. We say sub 1 because this is a subscript that's down below, but it would be A sub 1. The second one would be A sub 2. A sub 3. 23 would be the A sub 4. The A sub 5 would be 27. The A sub 6 would be 31. So, that little subscript simply identifies which of these terms are we talking about. Are we talking about the first one, the second one, the third one, the fourth one, the fifth one? And we use we use this a sub n to mean whichever one you want. Okay? So here we go. Let's kind of walk through what all this means from there. So if I've got a sub n, let's say that's a sub 6. To find a sub 6, which you already know is 31, you already know it, but let's say you wanted to know it. You go a to the n minus 1. Well, what's n? N is 6, right? So what's n minus 1? Well, n minus 1 is 5. So a to the 5 plus 4. So basically what this is saying, if I want to know what 6 is, take the one before it and add 4. If I want to know what 7 is, take the one before it, n minus 1 to get 6, and add 4 to it. If I want to know what 457 is, take a of 456 and add 4 to it. That's what the n minus 1 is. N minus 1 simply says the n minus 1 means the item before a of n, a sub n. So a subscript n minus 1 simply means the one before the a sub n. Okay? And this one can literally be whatever you want. It can be the first term, it can be the second term, it can be the third one, the fourth one, the fifth one, the sixth one, the 457th. Okay? It can be whichever one you want. Let's keep on going. Oh, I take it back. Let's talk about sequence 1. Remember sequence 1 we did with the toothpicks? We had, let's build this equation for it. So for whatever a I'm looking for, whichever term I'm looking for, that would be a sub n, I take the one before it, so a of n minus 1, and we added 3. Remember, we started with 4, added 3 to get 7, added 3 to get 9, added 3 to get 10, added 3 to get 13. So whichever one I wanted, if I wanted number 11, I would take number 10, the one before it, and add 3. This case, if I want a sub 11, so let's do that real quick. If I wanted a sub 11, I take a sub 10 and add 3. Well, a sub 10 was 31, if you remember. That equals 34. All right. And remember, this part down here is all from that previous page, sequence number 1 with the toothpicks. All right. Let's scroll down one more. Next set. Scroll down to the next page. Move on to the next page. This one, hopefully you see that we are multiplying each one. We're multiplying by 2, multiplying by 2, multiplying by 2. Okay? So since we are multiplying or dividing, in this case multiplying, this is a geometric series. And that is an R, not an N. T-R-I-C. This is a geometric series. Okay? And this is the basic formula for it. So what this says is whatever term I want, if I want a whatever I want, I take the one before it, a n minus 1, and I multiply it by 2. So if you're thinking of these guys, if this one's number 1, this one's number 2, 3, 4, 5, 6. If I want to know number 4, I take the one before it, and I multiply by 2. 0.08 divided by 2 is 0.16. If I want a number 5, I take the one before it, and I multiply it by 2. If I want to know number 8, I take the one before it, and I multiply it by 2. So if I wanted number 8, equals 2 times whatever a of 7 is. In this case, a of 7 was, what, 1.28? So a of 8 equals 2.56. And that's the nuts and bolts of what we're doing today.